What's up, guys? So let's talk about polynomial operations. So specifically, we're going to do adding and subtracting polynomials, and we're going to talk about multiplying polynomials. We'll also talk about dividing polynomials in another video. So this is pretty easy. Adding and subtracting polynomials is really just a fancy way of saying combining like terms. Okay, so let's just take one for example. Let's say we've got 3x to the third plus 4x squared minus 2x plus 10. And I'm going to take this polynomial and I'm going to add it to another polynomial, which would be 5x to the third minus 6x squared minus 7x plus 2. How do I do this? Well, as it turns out, all I got to do is combine like terms. So what are my like terms? 3x to the third, 5x to the third. Since there's a plus in the middle, all I got to do is add these two together. 3x to the third plus 5x to the third gives me 8x to the third. Look at my squared terms. 4x squared plus negative 6x squared. Positive 4, negative 6, put them together, we get minus 2x squared. And negative 2x plus negative 7x, since they're both negative, combine to make negative 9x. And then we have 10 plus 2, which is 12. So there is an example of polynomial addition. So let's look at an example of subtraction. So we're going to do negative 4x to the fifth plus 3x squared minus 24. Notice we're kind of skipping our powers here. Went from 5 to 2 to a constant. So, we don't always have to have a term for every power of x. And from this, we're going to subtract 5x to the fourth plus x to the third minus 2x squared plus 6x plus 5. Again, notice we've got some numbers in one parentheses which are not in the other parentheses, and so we're going to have to be careful about how we add these together, or in this case, subtract these. So again, it's combining like terms, but you're combining with subtraction, so just be careful about that sign. And since everything in here is in parentheses, everything in here is being subtracted. Some people like to drop the parentheses and change all the signs. I'm not one of those people, but if that's what you want to do, then that's fine. So combine the like terms. Well, there's no x to the fifth over here, so I'm just going to write that one, minus 4x to the fifth. Next, as I look through here, I see there's an x to the fourth. Well, there isn't one over here. So I'm going to subtract 5x to the fourth, but there's nothing to subtract it from, so I just write minus 5x to the fourth. Again, be careful. That minus sign means I'm subtracting it, so another way of thinking about it is that I have to change that sign. Now, are there any x to the thirds? Yes, there's one right here. Again, not one on the left, so I'm going to do minus x to the third. Now, x squareds. I have one in each parentheses. 3x squared minus negative 2x squared. Minus negative 2 actually just means plus 2x squared. So 3x squared plus 2x squared makes 5x squared. Do we have any x terms? So you might want to go to that constant, but you can't because we have an x term here. So we got to deal with that first. Again, nothing over here to combine it with, so we're going to say minus 6x. And finally, the constants. Negative 24 minus 5. It's already negative, and now you're going to subtract a 5 to make it more negative. It's going to be negative 29. And this is an example of polynomial subtraction. Okay, so let's talk about multiplication. Now, we've multiplied polynomials before. You've been doing it for a while if you're in Algebra 2. But let's start with a simple example just to kind of remind ourselves. An example of polynomial multiplication might just be two binomials. Maybe you've got something like 2x plus 3, and let's just say we're going to multiply that by 3x minus 4. Just making up some numbers. Let's just multiply those together. Now, some people are familiar with the FOIL method. And to be honest, this is kind of what I'm going to do in my head. And FOIL stands for first, outer, inner, last. But what it really just means is we're going to multiply everything here by everything over here. Some people like to use the box And this is the method I'm going to use because once we start multiplying bigger polynomials, this box is going to be really nice. So even for people like myself that would just multiply everything times everything and combine the like terms in their head, that's fine for one like this. But when we get to those bigger polynomials in just a minute, you're going to really wish you had a box to keep it organized. And all the box does is it acts like a graphic organizer. It's going to organize everything so that as you're multiplying everything here by everything here, it's nice and organized and it's easy to keep track of what you're doing. This is just a way to make sure that everything here gets multiplied by everything here. So 2x times 3x is 6x squared. 3x times 3 is 9x. 2x times negative 4 is, negative 8x. And negative 4 times 3 is negative 12. Sorry, I got distracted there for a minute and lost my brain. Let's check. 6x squared, 9x, negative 8x, negative 12. Okay, so now we just need to combine the like terms. And as I look here, I see that those two terms need to be combined. So I'm going to say 6x squared, negative 8, and 9 make positive 1x minus 12. All right, so what happens if we multiply some bigger polynomials? Well, we're actually going to do the exact same thing. There's nothing different about it other than it's just going to be a few more steps. So let's go ahead and jump to one of the biggest examples. Let's do a 3 by 3. We're going to do a trinomial times a trinomial. That's 3 terms times another 3 terms. So I have my trinomials here. 3x squared minus 4x plus 5, that's a trinomial, times 2x squared plus 3x minus 1. I just made some numbers up. It's not a big deal. It's going to work the same no matter what numbers we use. We just have to make sure, like before, that we multiply everything in this parentheses times everything in this parentheses. That's going to be 3 multiplications times 3 multiplications, so 9 multiplications. Let's make a box like we did before. Just make it maybe a little bigger than you did before. We need 3 rows and 3 columns. For every term here, make a row. For every term here, make a column. I think I said that backwards. Rows, columns. All right. And it doesn't matter which one goes where as long as you got the right number of rows or columns. 3x squared minus 4x plus 5, 2x squared plus 3x minus 1. Okay, and let's just multiply each row and column together. So here we're going to get 2x squared and 3x squared, which makes 6x to the 4th. This will be negative 8x to the 3rd. 10x squared, 9x to the 3rd, minus 12x squared, 15x. And now this row is going to be easy because all we got to do is change the signs. Notice it's just negative 1, so it'll be negative 3x squared plus 4x, negative times a negative, and minus 5. And just like before, we got to go through and look for like terms that we can combine. Well, we've got an x to the 4th that we can't combine with anything, so we'll start with that. 6x to the 4th. Now I see I've got a couple x to the 3rd terms here that I can combine. Negative 8 and 9 is going to make 1 x to the 3rd, so I'm going to say plus x to the 3rd. I need to combine the squared terms, which are going to be in this diagonal here. So negative 3, negative 12, that's negative 15, plus 10 makes negative 5 x squared. I need to combine the x's. 15 and 4 makes 19. And I have a negative 5 at the end. All the terms have been combined. I have no like terms that I can't combine. This is the product of these two trinomials. And that's the basic operations with polynomials.